So I want you to talk to us about what is the most appropriate path of science for our children to follow for success, and so they love it and learn and grow and thrive.
Yeah, thanks, Robyn. That is a fastball over home plate. It's something in our very fabric, going back literally decades in terms of the history of our group, our community. It comes down to this. It's really straightforward. If you go to any biology research laboratory, walk into the laboratory, you're going to see people in lab coats and look at the chalkboards or whiteboards, whatever they have up there where they're expressing their ideas. Look to those chalkboards, and what are you going to see? You're going to see structures of adenosine triphosphate, of deoxyribonucleic acid. You're going to see molecules. You're going to see that on that chalkboard or whiteboard. They're presenting chemistry. That's because biology is the history of life. Now, you can't get much more complicated than that. Now, walk into any chemistry laboratory and you look to the chalkboard. What are you going to see? You're going to see the physics of the atom, right? And then you walk to any physics laboratory, you may see a lot of math, right? Because math is an excellent language for describing the ideas, the concepts, the rules of nature. So there's this natural sequence where physics is the foundation. It's where you're learning about how things work, be it electricity, Coulomb's law, gravity, or what have you. It's the start. It's really the start. And then from that, you can apply it to this crazy world of the super small, the atom, and apply those rules that you learn from physics to the atom, and you have what we call rhymes with chemistry. That's right, chemistry, all right? And then you take all that you learn in chemistry and you apply it to life, and you have biology. So it's this natural sequence. And people wonder, well, then why are we teaching biology first? And there's a history behind that. When you had in the early 1900s, the development of high schools, and after the Industrial Revolution, figuring out how are we going to educate our kids. And a prime reason for educating our kids was to put them through the grinder so they could go out to the mill and learn how to become workers, So you only needed to get through, you didn't even need to read. But things started changing in society, and we were realizing we need a more equipped populace of people. And so that goes back to education. And what did we have at that time in the early 1900s? Physics was just entering this realm of quantum mechanics and relativity. And it was like, whoa. And at that time, they're like, you're going to teach physics to my kid? Are you crazy? Yeah, you would have been crazy at that time, absolutely. Biology at that time was a matter of looking at a tree and seeing if the leaves are oddly or evenly pinnate, trying to identify what it is, the lineal classification system. A lot of that was just memorization. Memorization's easy, just some flashcards like this, and you're going to be able to spit it back out. Doesn't mean you understand it, but you can spit it back out. And so because of that accessibility, because we weren't so advanced in that, we didn't even know what DNA was until the 1950s, right? So biology was the natural to be the first science to be presented to the student, right? Well, that was back then. And anything about the educational system, in many large systems like that, it takes time for it to move. It's got a lot of inertia. So through the years, it's just been a difficult thing to change. And what happened in the 1960s, remember, the 1960s, the space race, Sputnik, that whole Cold War thing started back then. And then suddenly, the Russians put the Sputnik satellite going over us. We're like, that's Russia right up there above us. And that was just a paradigm shift. Suddenly, you had programs coming like from MIT and Harvard called the PSSC program, where they're like, whoa, we got to boost this physics thing here. And so there was in the 1960s of, we're going to get the space race. We're going to get to the moon first. And so we're just going to buckle down and we're going to really do that. And that did not help at all with the idea of bringing physics first. Then in the late 1960s and 70s, that's when Paul Hewitt came along. And he said, wait a second. Yeah, that's important. But all these, you're talking about maybe 2% of the population, if that. I've got 90% of the population sitting in my physics course, and they don't need that at all. They need to understand why the sky is blue. Is there gravity in space? Just the basics of their natural environment. And by that time, the early 70s, that was known. And so what he did was he repackaged the physics in terms of what he called the conceptual approach, where it's welcome. Let's delight the students with the ideas of their natural environment. The world of physics is the study of the rules of nature, where we live, our natural environment. So he did that to great success. It was the most popular course at the City College of San Francisco. He was the moneymaker for the department because there's always overflow, and they just made the classrooms larger and larger and larger. We're talking early 1970s. And so he decided, well, I think maybe I should write some notes to accompany this course. And those notes evolved into what became the Conceptual Physics textbook, first edition. So that, interestingly enough, became popular, not just at his campus, but other campuses. Little Brown was the first publisher. And he essentially invented physics for poetry course, and it got that name of, oh, that's just for poets. But no, if you actually dug into it, you'd realize it's for everyone, including the engineer science types who would move on. It is a stepping stone for those higher math-oriented courses. Because if you're plugging and chugging the math, wouldn't it be a good idea if you understood what the math represented? Because the two aren't necessarily the same. You might be able to manipulate that equation, but then ask the student, what does that equation mean? That's going to be different, you see. So everyone can benefit from this conceptual approach. And so that's Conceptual Physics by Paul Hewitt. So he grew up through that and became more and more popular, and the book is still used widely. I'm sorry. So that's the background, and he's basically our founder. And that's awesome. Now we're in the 21st century, rocking the world also in terms of video. Yeah.
So John, so what do we do now with so you've written these textbooks, you've made resources available so we can teach science to our students and our children in ways that I loved when you said that they would delight. So where do we start, and at what age? I'd love you to even say what you think we should do at a grammar school level. Like, what should my third grader be doing in science to prepare them for success?
I am not an expert at the elementary school level, though I am a dad times 4. Yeah. And uncle. So this is what I know. And this also comes from my going to elementary schools as Professor John, coming in and doing the fun science. Yeah. Oh, that's so much fun. Is that there's so much available to the young kid in terms of the experiential. right? You take a cup of water, a Dixie cup, right? There are going to be Dixie cups in the classroom, and they're going to be cards, 3x5 cards. And you take the Dixie cup and you fill it with water, and then you put the card on top of it, then you turn it upside down, and then you let go of your left hand, and the card sticks. And the water doesn't come out. Of course, you do it over a bucket because sometimes the water does come out. But the kids love that, right? And they're like, but there's water up there. Why isn't the water coming out? You know, that's experiential, right? So my understanding within the primary schools, as experiential as it can be, the better. And it's not until middle school and high school years where you start switching over to more content oriented. But by that time, the kiddo has had the experiential, so they come together and certainly continue with the experiential on up past your PhD, whatever you want to do. So this is where I think we step in when it comes to middle schools, because we're content experts. That whole realm of working with the child and their development is like, I'm like, whoa, I need to learn a heck of a lot more to be able to specialize in that. But when it comes to content, that's what we've been doing, and so that's why we reach down to the middle school level. That's our uncomfort zone. We're like, okay, right, yeah, but we're not going to go any further than that, because we're digging into the content is what we're doing. We have our pedagogy, which we know that works, that we adjust it as we need. So we start. That's why you'll find at Conceptual Academy we start primarily at the middle school level, and then once we get to the high school, we're like, let's do this, and we rock and roll. Yeah.
So my youngest is going into 9th grade. I missed the middle school boat with you. So you and I have talked about the basically, I think we arrived at 3 different tracks of science, whether we're looking at your average student, average in quotes, an honors level course, or I think what we almost termed a super honors level course. It's a kid who was born to live and breathe science. So how do you determine where to place your child for success, and what are the approaches? So let's start with me. What do I do with my Juliana next year walking into 9th grade?
First question I've got is her experience with middle school. Right?
Right.
You'll look carefully at our course pathways document, and you'll see that we have conceptual physics recommended for the 9th grader, but only for the 9th grader who's gone through our explorations titles, who's already gone through our middle school curriculum, because we're not too confident in terms of if they haven't done that already, to throw them immediately into conceptual physics.
Right.
Yeah. So if Juliana is strong in the science and you feel she has a good foundation, and more importantly, she has good curiosity, it's not so much that they understand this concept, they understand that concept, and then now they'll be able to kind of go over here. No.
Okay.
It's how curious they are, how enthused they are, how interested they are. Because if you don't have that, if you don't nurture that, you're not going to be able to push appropriately, right? So if a student comes in to the 9th grade, regardless of having gone through our explorations titles or not, and they have that itch, they're ready. You'll know far better than we will. Yep. If they're curious, then the answer is yes.
Okay.
Conceptual physics, 9th grade.
Where does their math level have to be? Because I think that for most of us has been what we've been told. That's why we do physics in 11th or 12th grade. Because
you see it back in the early 19th century.
Right.
Right. Let me bring
I'm living in the past.
Up to the 21st century. Yeah. Because remember, there's the conceptual, And the conceptual is the focus on the physics itself.
Okay.
You know, build a really tall tower. Can you hear me?
Yeah.
Yeah, build a really tall tower. I mean, really, really tall.
Okay.
Larger than that one over in the Middle East, you know?
Okay.
Pick a number.
12,410,000.
No, smaller than that.
Okay, sorry.
300? 300?
Sure. Yeah, you have to give me a range.
Okay. Kilometers or miles?
Miles.
No, okay. That's longer. 300-mile tall tower.
Oh, this is my height of my tower. Got it. Okay.
Oh, wow. That's a really tall tower you just built now, isn't it?
Yeah, it's fallen over.
That's a tall tower. Okay. Tell you what. It has an elevator in it. Let's go up it. Shall we?
No.
Will that be fun? You don't have to worry about wind because the wind is only down here. We're going to go up this really, 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 really tall tower, right? And so, the elevator broke. We have to walk. Okay, so we walk up the elevator, walk up the staircase, up and up and up and up and up and up. Pretty soon you start to notice something. What?
I can't breathe.
You can't breathe. Why not?
The air is too thin.
The air gets thinner and thinner and thinner. You see, air is held down by gravity. You know, if it weren't for the gravity, all the air would just go away. And that's why there's not much atmosphere on the moon, because the gravity is not strong enough to hold it down, right? So thankfully, we have enough gravity to hold down an atmosphere and we can live. But this tall tower, and you climb above that atmosphere, the first thing you notice is you can't breathe. So you put on a helmet. Let's call it a space helmet, space suit, right? And there you are. Whoa, what a view. You finally get to the top of that, what was 300, that's up there, 300-mile tall tower. Wow, you can start to see the curvature of the earth too, right? And you are in rhymes with space. You're in space, okay. Now, let's go to the edge of that really tall tower. You ready? You with me? And you happen to have a rock in your pocket. And you pull out this rock. And you're at the very edge of this tall tower. You're going to let go of that rock. You're in space. What's that rock going to do? Is it going to hover right there? Is it going to go up? Or is it going to go down?
I'm stuck on the idea you think I'm walking 300 miles with rocks in my pocket.
All right, you had the elevator.
I took
so
yours.
The elevator to the top, you get out, and there you are, and you're on. You look at the edge. Whoa, that's a long way
That's
down.
a long way down.
But if I pulled out this rock from my pocket and I let it go, what would that rock do? Here you are in outer space with a helmet on.
But the rock is not.
Yeah, and you let go of that rock. Is it going to go up? Is it going to hover, or is it going to fall down?
It's going to leave me. It's going to up, right?
What's holding you to the top of the skyscraper?
I'm assuming I'm adhered in some way, but maybe I am not.
You are adhered by something starts with G.
Gravity.
Gravity, yeah, there's gravity. So rather than holding it over the edge, why don't you hold it over here and let it go? You're not floating. At what point climbing up those staircases do you start floating? The answer is no point.
Oh.
You're being held down by gravity the whole way. Okay, it's a little bit less. Look at that. It's one of those scales that you step on and it gives you your fortune, you know? Oh, you got to put a quarter in there. So I take a quarter out and I put it in that, you know, those scales you step on to give you your weight and your future? And you put a quarter in, you step on the scale, and the scale reads, well, whatever the scale reads. It's reading your weight. You have weight up there, right? And so you let go of the rock, and the rock falls down. There is gravity in space, so that's one of the biggest misconceptions out there. How is it then that the space shuttle stays up there, or the International Space Station, or any satellite? Take that rock and don't just drop it. Throw it sideways. Is it going to land at the base of the tall tower? No, because you threw it sideways. It's going to go sideways, but it's going to fall. But notice the curvature of the fall. If you threw it sideways faster, the curvature would be greater. If you threw it really, really fast, the curvature would be almost nothing at all. In fact, the curvature might match the curvature of Earth. And so it's going to be falling not into the Earth, but falling around the Earth. And you wait for 90 minutes, that rock is going to come right behind you because it went around the planet. And you're going to get out of the way, and the rock will go by like that. And that rock is in what we call orbit. And in orbit, it's perpetually falling around the Earth. If it weren't for gravity, that rock that you throw would just keep on going to the next galaxy over, right? It's gravity that is constantly pulling downward on the space station. If it weren't for gravity, the space station would be gone. Gravity pulls it down just as it pulls down the atmosphere. There is gravity in space. Okay, it's a little bit weaker, but not much. If you weighed 150 on the ground, you weigh maybe 146 up at the top of that tall tower. Okay, sorry, I went into a lesson.
Yes. Right?
But notice the amount of math that was in there. You know, we could go into F equals G times D1, D2, M1, M2 divided by D squared, and fill in the equation and figure out exactly your weight up at the top of the tall tower, and you would find it's just a little bit less than it is down at the bottom of the tower. Whoopee! Well, that's actually important because it's that very math that they used to get to the moon back in 1960s, before the advent of miniaturized computers. They were relying on the calculators who were human beings able to do that math amazingly.
But we're not making those equations right now. We're teaching the concepts,
the ideas that the equations represent.
They understand, and it has validity
Bingo.
To their lives.
And that has value for everyone.
Right. Okay.
From the voting citizen to the student who is science shy. Walk them through that. They're not going to be science shy anymore.
Right.
You see, you might as well say, well, they're nature shy. They don't like going outdoors on a beautiful day. No. Well, maybe some days you don't feel like going outside. But no, every human, any healthy human is going to be interested in their natural environment.
So the student,
and that begins with physics.
Okay, so in the student that's interested, I think what I heard you say before, regardless of, they have to have had some science, but can walk into this if they're curious and want to learn and succeed. What do you do about the child who is midway down the common path? What do you do about the child that has had biology their freshman year, is ready to walk into chemistry? Do they do your chemistry course, or do they circle back to physics first?
Again, it's based upon their level of interest. Okay. If they have gone into the biology, you may as well take advantage of what they've learned. They have learned stuff.
Okay.
And it could be this. They didn't learn stuff so much as they learned that they had questions. Uncle Paul would always say that your education is the flavor that remains after all the facts and figures have been forgotten. And they may have gone through the biology, coming out with a pretty good flavor. That is to say, a pretty good level of curiosity. Yeah, I was kind of confused by that DNA thing. The teacher, she was trying to get into replication and messenger RNA and vaccines and stuff like that. But I don't quite remember the difference between an atom and a molecule. Chemistry. And then you might go, but wait a second, shouldn't they go into physics first? Well, no, in that situation, go for the chemistry. They already have a context of the biological world. The closest to that is going to be the chemical world, right? So go into the chemistry. And then, hey, you're working backwards. That's fine. then after the chemistry, you're going to go, but what about that quantum mechanical thing? I don't understand why energy can only be so much. We'll go into physics there. We are physics first by default. If that's we were given a choice, we would do that. That's not to say all other paths are wrong. No, every path is correct. It depends upon the student. They're going to find value, right? Okay. So for the student who comes in having had biology first, no worries. I'd recommend, depending on the student's interest level, jump into chemistry. Okay. And then to physics. Though, our tendency is to lean toward physics first when you can. And guess what? When you start conceptual chemistry, the first 2 chapters are going over physics, mass, density, all the physics that you need to know to get into chemistry. That's right there in conceptual chemistry, right? And within our conceptual biology sequence, guess what we're going to also have up front? Because we want to make sure everybody's on the page, right? So there'll be the bit of physics that's just quintessential, followed by the chemistry. And so that they'll get frustrated. They'll go like, well, this is the biology course. How come I'm having to do physics and chemistry? Absolutely. Maybe we'll put some application up front so that it pulls them in. Okay, I do that for the astronomy course. I put the solar system up first, and then we jump into the physics. Right. There are ways around that. So
I want to talk about astronomy, but I want to go back because chemistry, you actually have both conceptual chemistry and contextual chemistry, correct?
Yeah.
What's the difference, and what's for who takes what?
That's a rabbit hole. So please stop me.
All right, I will. But give me an overview.
Okay. Okay. So now we're jumping from the world of the beautiful fundamental world of physics into chemistry. Chemistry is the study of the atom, how it behaves, and how you can take atoms and put them together. If you like Legos, who doesn't like Legos?
I have a 3,200-piece Star Destroyer on the top of my desk.
The sound of a Lego kit, you shake it. Yeah. We have our Legos are downstairs. Our kids are in college and they're still playing with their Lego sets. Anyways, that's what chemistry is you're taking the atoms and you're putting them together to form these things called molecules. My training is in drug design, right? Where I thought I was going into the pharmaceutical industry, whereby I'm the guy who will take these atoms and put them together to form a molecule that could potentially be used as a pharmaceutical, right? Then my life went another way. I met my Uncle Paul. But that's an amazing thing and very powerful on top of that. So the conceptual approach there is to talk about our universe from the perspective of atoms and molecules. Because when you see the universe from the perspective of atoms and molecules, it's enlightening. So taking your dog out for a walk, the dogs smell in color. They so do. And especially if you have a basset hound, right? This is a walk with a basset hound because they're smelling, right? They'll tell you all the stuff that's been going on in this one little corner based upon the molecules that they're smelling. And I saw an article showing the other day how dogs are able to smell whether you're infected with the coronavirus or not. They can detect whether you have cancer. It's just amazing. And as a chemist, there's this cardinal rule: if you can smell it, if you can smell smoke, there's a fire. It's just a given. If you can smell it, it's there. You can't go, oh, maybe it was just an illusion. No. The molecules are coming up your nose and hitting there, and it's telling you, hello, there's smoke, right? And the same thing for the dog on the walk, smelling down. They're getting this whole history of what's going on. So to have that perspective, you put perfume on, right? What's going on there? Oh, it's perfume. No, you have molecules just coming up like this, right? And you're taking a you're going for a jog and you go past somebody, maybe they're on their bicycle, boom, like this, and they're wearing aftershave or something like that. And a moment later, you're like, what are they tuning that for? Because you're smelling it, right? The atoms and molecules are so small. Context is that, hey, we're wearing masks now as we go outside. If you don't understand how small these things are, then you're not going to get it. Think of what the dog is sensing. Think of what you sense when you walk past somebody. Those molecules are so small, they spread all over the place. Robyn, they're finding plastic fibers in Lake Superior. Lake Superior doesn't have major cities around it, yet they're finding plastic fibers within it. Not like Michigan. How did they get there? Turns out the fibers within the laundry that we do escape into the atmosphere, and there's this hovering cloud of plastic fibers around us, and they just spread everywhere, including landing in Lake Superior where they can measure them, right? Talking about issues like climate change, right? With carbon dioxide. Well, what is carbon dioxide? The ideas of chemistry are as germane as could possibly be to our 21st century modern life, right? Conceptually, you learn the ideas of chemistry. Contextually, you learn how those ideas apply to our everyday living, right? So my book is called Conceptual Chemistry, and we just plow right straight through it, the concepts, and I integrate the applications, absolutely. But that's not how I've actually taught my course in like 2 decades. I teach it sideways. I start with some basics, and then I jump right to chapter 16, because I do want to get to climate pretty soon, environmental stuff. Then we get to energy sources. I'm going like this through the book, right? And that I call a contextual approach. Right? Then you could do this, because there's so much within conceptual chemistry. It's the concepts. You can go and say, well, what if I'm interested in becoming a nurse, right? I don't necessarily need to go into the environment, although I'd recommend you do. But you want to get to the genetic engineering. You want to talk about organic chemistry. And so there's another sequence you can do that I've spelled out that provides the life science chemistry course that we offer. And then there's a fourth one for prep. Those students who just want to get those numbers right away. Because we have math in conceptual chemistry, don't get me wrong, but the focus is on the English. And so the prep focuses on those concepts that do have the mathematical oomph behind them, like stoichiometry, if you know what that word is. And so that's how it is. We have those 3 variants of, 3 flavors of conceptual chemistry. I don't want to call them the shorter versions. They're not. They are a full year curriculum. And working with Homeschool Planet and those planners has just been like to my head that full version of conceptual chemistry is a lot for the high school student. Mind you, my handicap, I'm a college professor. So to scale it to the high school has been like a learning process for me, and thank you, Homeschool Planet. Like Robyn, it's just been amazing in terms of helping us in the development of our curriculum so that it is appropriate. So that conceptual chemistry full version is about to switch to honors.
Yeah.
Because that's what it is.
Oh, yeah.
So, and we'll be doing the same thing with conceptual physics. The full version of conceptual physics is about to transform to an honors level. You may have that student who has that itch, and they're just gonna right at it. Let them. And then we're gonna have a scaled back version of conceptual physics. I'm working on that now. That'll be just the regular, which is where we will point most people.
Okay.
You didn't stop me.
So I didn't, because it's all so much. But then I'm also thinking about the mom who's listening to this who has no idea still, like, how do I know what my child is? So curiosity, number 1.
Yeah.
what piques their interest, what draws excitement out of them. What about the mom who does not have a science background? Tell us how you've done it for us.
I want to say the planners have done it. We have the content out there, and again, a mea culpa on our part is like, well, here's the content. Go ahead and you can figure it out. It's all there. You're not going to go wrong. Yeah, we'll go wrong, because as you're saying, someone who doesn't have that background, who can't go and say, well, we can skip over this because it's not really essential to that over there. Well, they've never taught that course before, so they wouldn't know. Just as I wouldn't know if I were doing a primary school lesson and they'd say, John, you messed up. You forgot that. Oops. So that's where the planners come in. And 2 points on that. One, Robyn, those are grueling to make. They are grueling because you're going into the nitty-gritty detail. But man, I'm so happy after they're done because I can put in Easter eggs, and just little things in there. And you know what? It's helping me to be? It's helping me to be the teacher. Because I'm sorry, and you know this well, Robyn, that I've gotten into the business side of things here. We've got like 70 college campuses using Conceptual Academy. I got to manage those. We just secured a huge adoption in California for a high school system. I got to manage those. I got to do all this stuff. And when I'm happiest is for teaching. Okay. Did you see how much fun I was having talking about the elevator? All right. And the stalls. That's what I love. All right. And so it's been like the planners have given me a soapbox, a platform to do just that. And so I'm just forever thankful for
we are grateful to have them.
That. Yeah.
I want to circle back to a couple things, but I want to touch on astronomy because that came in just for a moment. Where that course falls in the realm of things, because it's a trick to get to physics, is what I have gathered. Is that correct?
Sorry, it's a what?
It's a way to trick kids into learning physics.
Let me give you a warning there. Relative to applications versus conceptual. And I have to deal with this in terms of the contextual course. Two approaches. One approach is to go in and think, yeah, these students just, they just don't have it. And they're not interested in the science. So, they'll probably be interested in some applications. Yeah. So we're going to make it all applications based. So it's going to be, kind of like reading a newspaper, and we're going to sell it to them that way because they're just not naturally curious about their environment. And it's just going to be applications of physics, applications of chemistry. It's kind of selling oneself short as a human being. And that hits a sore spot in me because one of my competitors in the chemistry level is all that. And it just drives me crazy, especially in that they're doing well. The reason they're doing well is because they're the American Chemical Society and they're huge. And so they have the weight of their, and professors who are like, yeah, I like that. And they go, let's throw them the applications, right? So that's my caveat there in terms of you have a student who's not interested, and they're genuinely not interested, which is fine, which is absolutely fine because they'll have other interests, which we need for them to have. But to placate that, to say, well, okay, well then we're not going to do the physics, we're not going to do the chemistry, but we'll talk about the physics. We'll talk about the chemistry. I disagree with. I would argue every student would be interested to know why the sky is blue. I would argue every student would be interested to know what that dog is doing. So what's going on there? About smelling a rose, what's going on? Those ideas there are not applications. Applications are important too. Love Canal. Let's talk about what happened there. That's hugely important, right? But it's based upon the concepts. Concepts first. Make sure that that's given its due diligence. And when you have that concept down, then, and only then, you can walk through Rocky Flats plutonium facility where they made the plutonium buttons for the nuclear fusion bombs. And someone can tell you, this is where they made the buttons for the ignitions for the fusion bombs. But understanding nuclear fission and fusion gives you a much deeper perspective of like, whoa, we did that. Yeah, so the two are important, but I would argue the conceptual comes first.
Awesome. I'm listening and I'm looking, so I'm just going to ask John Wright to do this for me. Can you put a link in the chat to the Pathways document? Because that is so helpful on a practical level of understanding and putting some legs to some of this, so people know where to go in what order. He'll do that.
Yeah, we and that was based upon feedback from homeschoolers actually, and you'll find a flow chart within there. So it's like, are you a seventh grader? No. Okay. Are you a ninth grader? Do you have interest? And then so there's this whole logical flow chart of directing the students, and you may have noticed that document has been changing markedly over the summer. Again, on account of Homeschool Planet and these planners.
We all met back in April and thought, what can we do to make John's life more busy in the busiest season ever?
Darn you.
We have a question. Elizabeth asked, can you speak to the structure of the Homeschool Planet lesson plans, sharing the thought process so the parent-teacher can make most of the plan, and are the appropriate podcasts included in the lesson plans?
Yeah, the last part of the question first. The podcasts that we've created right now are in chemistry. My wife and I go into the closet literally because that's where the acoustics are best, yeah. Right? Yeah. And we go through the textbook. We don't read from the textbook. We'll get to a section and Tracy will ask, well, what about, and I said, well, blah, 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 blah. And she's, well, no, blah, blah, blah. And I said, blah, 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 blah. And so we're dialoguing back and forth over the content. Meanwhile, we also have interviews with people. We had a feather in our cap with Raj Rajeshwar. He's one of the lead researchers in the area of solar fuels. Solar fuels. What's solar fuels? That's generating not electricity from sunlight. It's generating fuel from sunlight. I'll let you think about that for a little bit. So we have a podcast episode on that. And so we did the Rocky Flats tour and things like that. So we have fun too. It's on our list to go to the recycling center and have an audio podcast of what's going on there. That's within the realm of chemistry. So within the chemistry planners, you will find the links to the episode that relates to that particular lesson for that day, right?
Okay.
So we don't have that yet for the physics. And as soon as we do, then we'll naturally embed that into the planners. Okay, so in the first part of the question, how are those planners structured? Right. I go through the Carnegie unit thing was 180 days for a school year and 360 days for 2 school years. And I took that to heart. Okay, that's starting point. I know it's 120 in some states and whatever, but I just went 180 days. And then I paced it from there. And I'm that's one of the harder parts is making sure I reach to that 180. And I'll be like maybe 185 or 170. And I'm like, close enough. Because I'm expecting the parent to know this was supposed to be one day. Actually, we did in 10 minutes, right? And over here, oh my goodness, there's a lab activity involved in there. That's going to be longer. And note when we say the duration, it's definitely an average duration. Now, this is going to be different from something like math, where it's going to be more scripted. Do 10 problems, and that's going to take you so many minutes, right? We're talking about the experiential science, learning about your natural world. It's going to have more going on there, and so saying this is 45 minutes per lesson is my best guess. I fully expect parents are going to find a wide range, and with that, maybe it's like surfing. They're going to be able to ride with that, and they realize, oh, we're a little bit behind right now. Maybe we should pick up, or maybe we're a bit ahead. Maybe we should slow down. But the number one thing I would want to point out to that parent is, don't worry about it. What's most important is that your student is engaged and they're enjoying the process. It's not about stuffing a bunch of content into your brain. It's not. It's about having an experience that turns the student on. You know, you're going to say, but wait a second, that means we could just cover the first unit over the full year and not get to any of that other stuff. Yeah, that's what it means, you know. So my recommendation is to relax on it. It's important, definitely important to be with a program, but homeschoolers know this best. It's most important to be with your student, to their particular needs, which you know best. We're just the content people, you know. We're giving some guidance there as best we can. You're in the steering wheel, and I think the planners. I think of the planners as being a wonderful map to make sure that you get through those pathways, and you're in charge. You've got the responsibility there. Let it breathe and understand you don't have to get to day 180, and your student's going to do really well as they move on.
Yeah, that's hard for some parents.
Letting go.
Yeah.
Yeah.
Yeah. So, I want to, if you guys have any other questions, please send them in. We have hit the 1 hour mark, but I want to ask any other questions that come in. And I'm trying to think what other questions I have. Thank you, John, for posting that pathways. It's very helpful. And even, well, it's not static because there are so many options, right? Of where to go and when, and being, I love the, excited by science is my favorite question on here.
Yeah, because that's an important qualifier. You'll know, and it has nothing to do with the parent. It's all the student.
Right.
They're so different. Each kid, and you'll know. And then so this is to lean you one way or the other. Yeah. And you'll have questions if you have questions about particular sequence. Contact us at support@conceptualacademy.com. And we'll do everything we can to answer those questions.
Awesome. And real quick, I want to touch on, because we went back and forth a couple times about middle school versus junior high. I went to high school in the 80s. So in my world, there's junior high and high school.
Yeah, me too.
And my local district, of course, is middle school, which is now more commonly accepted when you are which is, at some places 6th, 7th, 8th, and at other places middle school is 7th, 8th, and 9th. And obviously the bottom line answer is know your child to know what they're ready for. But in general, is 7th grade an appropriate jumping in point for the exploration series? Or can you do 6?
Yeah, I go back to our daughter. She went through the Waldorf system. Mm-hmm. And I remember going into her 6th grade class to be, the special teacher for the day. And I go back to that experience a lot. It's like, I'm like, oh, okay. That's sixth grade. Okay. So maybe there's something that happens between sixth and seventh, but it's still a spectrum, you know. So seventh grade, it's going to depend on your student. As you said, Robyn, the seventh grader might be developed as a fifth grader at that point. You might have biologically a seventh grader, and they're developed as a 10th grader at that point. That there's such a range. It's got to make it so difficult for teachers when you have such a range of students. You know, who do you teach to? So that's where it's nebulous. It's not concrete. You're a seventh grader than this. No, you've got to be able to make your decisions on who the student is. Seventh grader is just, I think, the ballpark of the level that we start at. Yeah, and thanks for the middle school, junior high school thing. I had to change all the language on that too.
Again, I'm just working to make your life harder.
Thank you. For all good reasons.
Thanks so much for doing this today. I appreciate it. It's been really helpful for me as a mom, as I'm determining the best places to put my own children. And
Juliana's going into a contextual chemistry course.
That's Hope. So I have Hope, who is going to be in 11th grade and going to do, I believe, contextual chemistry, and then Juliana is starting 9th grade, and I think we're going to do physics. Okay. Although there's probably an argument to be made for putting them both in the same course when I think that about that out loud.
When you have two students working together, that works well. Well, depending if like some twins, I know they just like they have to have their own separate things, but it can work very well. Even if one's older, the best way to learn is to teach and let the older student know that, well, if you understand this, if you really do, you'll be able to teach it to your younger kid, your younger sibling, okay, go ahead, try. And then suddenly it's difficult to, and they realize that's a learning experience. And the unit exams we have within our courses, you'll see the instructions ask the family to take the exam as a family and bring in other friends as well if they're available.
I love that.
Because they're a social thing going on with the way our exams are taken. And when you have two students in the same class, they'll get to take the exam together. Right? And it becomes what we call formative assessment, where the exam itself is a learning experience. So if you can put them together in the same classroom, there are advantages to that.
Well, and Hope was going to be doing it with some friends. It's funny, though, I'm thinking, because I'm a history lit gal. That's my groove. That's what I love. Yeah. And I tell every parent, like, don't teach one American history, another world, another, ancient, one's in modern. No, all at once. So we cycle through. Regardless of your grade, everyone in the family's always been in the same topic. But in my mind, science is different. We do science in this prescribed order on our own. And so, it took me through this whole conversation to realize,
yeah, you'll see in the Paths document, I have a thank you to Dawn Reimer. It's a homeschooler. She's in Colorado Springs area now, I think. And she's great. And she follows Charlotte Mason primarily. And she's talking about interleaving, right? And that's what you're talking about too, interleaving the history. Let me tell you what she does with her children. They have them taking conceptual physics and conceptual chemistry at the same time. They do conceptual physics on Monday, Wednesday, Friday, and conceptual chemistry on Tuesday and Thursday. They take 2 years to do it.
Okay.
Right? They slow down, but they're interleaving, and there are advantages to that as well. With anything you're doing, there's going to be advantages and disadvantages. It may fit what you want or the student wants. It may not. What you need to understand are the possibilities. And so the sciences default physics, chemistry, biology, right? But you can even take biology first and then work it backwards if you have to. Sorry I had to say that, but you could take physics and chemistry, put them together at the same time. There are all sorts of possibilities. It just points to the truth that there are a zillion paths.
Right.
Each one has value, right? So.
So helpful.
I hope. Thank you so much, Robyn. We have gone over time. Clearly.
Of course we did. We're shocked about that, right?
Don't get us
We've
going.
never had a short conversation. All right. Well, thank you so much. If you all have any questions, again, send them in after. What is your support email? I'm sure it's on the site.
It's easy. support@conceptualacademy.com.
All right. And at Homeschool Planet, it's support@homeschoolplanet.com. So just support. And someone will get back to you. Everybody have a great day.
Okay. Thank you, Robyn. Thank you, everybody.
Thanks,
Thank you so
John.
much for joining us.